So this was the last question on your test paper, question 24. It's on the topic of vectors, and there were some good attempts at this. Lots of people scored an odd mark, or maybe 2 marks. I didn't typically give out 5 marks, though, to anybody for a full solution. Well done if you did get it, but here's how you do it. So the first thing the question is telling us is that this shape, OZYX, is a parallelogram. And I haven't copied that information down, but I am going to use it in a minute. In a parallelogram, the opposite sides are parallel and the same length. And the reason that's important is I can say things like OZ, the vector from O to Z, is the same as, identically equal to, x to y. And I can do that kind of thing in a minute, which will be handy. Now, the question is ultimately asking us to find what's the ratio ZP to ZR. Notice how there's no arrows above the top. So they're basically asking us to work out what the ratio of the lengths are. So ZP would be a certain length and ZR would be a certain length. And we don't have to work out what those lengths are exactly, like as a number in centimetres or anything, but we do need to know how much longer one is than the other. So what's the ratio of these two lengths? Now I'm going to put some of the information that's given to us on the diagram. We're told that O to X is a little a, O to X is a, so I'm going to put that down here. And remember, in handwriting that's underlined, but it's printed in bold when it's in typing. And we're told that O to Y is little b. So from O to Y, that's a little b. I'm going to put that on like so. And now, because this thing is a parallelogram, we know that the opposite side is also the same vector. So O to X is a little a. That means Z to Y is also a little a. And although the question doesn't ask for it, it seems, from my experience, obvious to me that we should probably work out this one as well, X to Y and O to Z, because we want to travel along those paths at some point in a minute. So X to Y, let's work out the vector X to Y. The first thing you do is work out what route you're going to use to get from X to Y. Sometimes there's more than one choice, but you haven't really got many options here. To get from X to Y using routes that we know, you're going to have to go from X to O, then O to Y. By the way, I should just say I'm trying to work out this side here, and I'm going in the direction X to Y. There's no reason why you couldn't instead work out the vector YX and do the whole problem in terms of YX later on. Right, so X to O, that's the wrong way along A, so that's a minus A, and then I've got to go the right way along B, so that's plus a B. And there's no need to do this, but I like to put the positive term first, so let's call this B minus A. Like so. So I know that X to Y in that direction is B minus A. And because this thing's a parallelogram, O to Z is also B minus A. Okay? And it wasn't clear that we definitely had to do that, but you'll see in a minute why we needed it. And it's okay if you don't immediately have the idea. If that didn't occur to you, then don't worry. You'll see that we're going to need it in a minute. Okay, now remember the question was asking us to work out the ratio length ZP to length ZR. We can at least work out the vectors ZP and ZR. Let's see what they are. So to get from Z to P, let's think about the route we're going to take. So that's from Z to P. Now I hope you can see why we're going to need this vector here, because the only way of getting from Z to P is to go either along here, then along here, or the slightly longer way around, along here, then along here, then along here. But either way, we would need this jump here. Okay, we'd need to know how to do that jump there. So as soon as you start writing out a route for ZP, you think, I'm going to need to know how to do this jump here. So then you would have thought to do that afterwards, hopefully. Okay, Z to P, what route? I think I'll go Z to O, and then O to P. And O to P is just some fraction of OX. So Z to O, and to get from O to P, well, OP is 1 part when P to X is 2 parts. So if it's 1 part, 2 parts, this length OX has been split into 3 parts. Therefore, I can say that OP is 1/3 of OX. I'll say that again slowly. If that's 1 part and that's 2 parts, then this is 3 parts in total. So this is 1/3 and this is 2/3 over here. So I'm going to write that as 1/3 of OX. And now I've written it like that, I can turn it into little letters because I know ZO is the wrong way along this. So that's minus B minus A. And then plus 1/3 of the OX, which we said at the beginning was little a. If I expand the brackets out, if it helps, there's like an invisible 1 there. I get minus B, and then minus 1 times minus a is positive a, plus 1/3 of an a. And I'm just going to shunt that up because I'm going off the edge of the page. There we go. And I can collect like terms now. Here's 1 whole a plus 1/3 more of an a. So that's 4/3 of an a in total. I'll put that first, the positive term, 4/3 of an a, and I've got a negative b there. So what I've managed to achieve so far is I've worked out the vector z to p. Haven't worked out the length z to p, but if I can see a relationship between vectors, I'll also know a relationship about lengths as well. So I've got z to p. Let's now consider z to r. So how to get from z to r, that's here to here. You've got some choices. Not sure one's any better than the other. I suppose you could go z to y, then y to r. That's not a particularly complicated route. You could go, so I'll just gesture that again because it was off the page. You could go z to y, then y to r. I think what I prefer to do is probably go z to o, o to r. That's the reason for that is although I've got a more complicated vector here, I've got a simpler fraction in a minute to deal with. Okay, z to r, I will go z to o, and then o to r. O to r is just some fraction of the whole jump o to y, and like I worked it out before, if OR is 1 part and RY is 3 parts, 1 part, 3 parts, we've split the whole thing into 4 parts, and so this is 1/4. OR is 1/4 of the whole jump OY. We've got 1/4 and 3/4 basically. And that's why I chose to go this way, because if I was going the other way, I'd have to have a minus 3/4 going on. And that's not especially difficult, but I think I prefer going this way. So Z to O, O to R. OR we said was 1/4 of the jump O to Y. And now I can fill in what I know. This is minus B minus A, because I'm going the wrong way along B minus A. And then it's 1/4 of the OY. We said OY was called little b. Let's expand this out. If it helps, there's an invisible 1 there. Minus 1 times b is minus b. Minus 1 times minus a is positive a, just like before, plus 1/4 of a b. 1/4 of a b, take away a whole b, is minus 3/4 of a b. Okay, so I've now got my 2 vectors zp and zr, and can you see any link between them? Well, maybe if I put this first, let's put the positive term first, it might be easier to see. To get from here to here, I multiply by one particular thing. Wonder if you can see, or if you prefer, to get from here to here, we multiply by one particular thing. I wonder if you can spot it. If I'm going from here to here, it's 3/4, isn't it? 3/4 of this is 1a, and 3/4 of this is 3/4 of a b. If I was going the other way, you'd say multiply this by 4/3 to get this one over here. But it's times by 3/4 if you're going in this direction. If you want to go from zp to zr, you multiply by 3/4. So that's telling me that zr is the slightly smaller one, which is no surprise. Zr is 3/4 of my zp. And so this is an equation, but I can write that as a ratio if I like. It may or may not be helpful to multiply both sides by 4. Maybe you'd like that. So maybe 4zr equals 3zp will help us to see it. This is the same as the relationship zp to zr is, well, zp is the big ones, this is 4 to 3. Okay, so 3/4 of this is the statement we had there. Maybe that line wasn't useful to you, but I mean, I did it because we did a fair amount of work in the past on switching between ratios and equations and so on. So possibly helpful. But that's the final answer. The vectors ZP and ZR are in the ratio 4 to 3. Therefore, so is the basic length ZP and ZR is also in the ratio 4 to 3.